Okay, starting page 6. Oh, okay. I'm graphing the start of the rectangle. Now they're telling me it's a rectangle, so I assume that x is a right angle. And what I know is that z's got to be in this vicinity. Okay. How do I know that it's a rectangle? Well, we're going to get to that. So what I was doing was I was counting from W to X, and I believe it's 2 that way, 6 this way. So I'm going to utilize that. I'm going to go kind of in the same direction, right? I've got to go from Y, 6 this way, and 2 down to locate Z. So then the Z is the coordinates. What do I get there? 0, -9, it looks like. Now, how do you know for sure that it's a rectangle? Well, they told me, but so I can't really say that and get credit. So what I'm going to do is I'm going to calculate the slopes of all sides. Okay. I can't really go with, well, I'm just going to use the same slope because opposite sides are parallel. I'm really trying to find out, how do I know for sure that it's a rectangle? So I'm going to get the slopes. The slopes, after I reduce them, are going to turn out to being negative reciprocals. I'm getting the slopes off of counting. The rise is 2, the run is 6 for this one. Rise over run. And I know it's positive because when we read a graph, as you move from left to right, a particle would be going up. For this one, I know it's negative because if I go left to right, a particle that travels left to right would be going down. So it's a negative. That's how you utilize that. It's going to be the same for YZ and WZ. So it's going to be a third for YZ. It's going to be a -3 over 1 for WZ. Okay, now what I found was basically these are all adjacent sides are all negative reciprocals. So I had to go on to talk through that. Every pair of adjacent sides, touching sides, have slopes that are negative reciprocals. Slopes that are negative reciprocals give us perpendicular lines, and perpendicular lines or segments create right angles. 4 right angles gives us a rectangle. So I don't know how many points that was worth. I didn't want to come up short on that explanation. I don't know if I had to get into all of that, but it felt like to make it a rectangle, it's got to be 4 right angles. Okay. The length of each side. So technically, you're supposed to show work for all 4 sides. I'm going to show work for 2 and just say that it's the same. Now, square root of 40 is, if I try it in my calculator, it's going to be a decimal, 6 point something. And it's better to leave the exact number unless they tell you to round. So I'm going to leave it as square root of 40. The other one I'm running, again, I'm taking the change in y, change in x, and I'm running the Pythagorean theorem, okay, to get the length from w to x and from x to y, okay? So that's where Pythagorean theorem is coming in instead of using the distance formula. All right, so zy is going to be the same length as wx. Don't ever do that. I'm out of room. We should actually show the work and just play the game a little bit there. Okay, that's it. So now for the area, oh, this is mean. It is a rectangle, so I can just use base times height. If it's a parallelogram, I couldn't do this, but since it is a rectangle, this is the base, this is the height, I can actually just use the sides and multiply them, length times width. Now, every unit is 3 meters, so the area is going to be, after I multiply these, I should say it's square meters, 540 square meters right there. Okay, now that's it for page 6. And again, we'll keep the videos 1 page at a time.